Okay, good morning, everybody. Nice to see friends and colleagues around the world on air pollution and clean air with an interest. The purpose of our presentation today is a bit of an introduction, really, to ESG and air pollution, and just to give you some thoughts to think about. I'm sure, dependent on the feedback of what we do here today, we'll do something in a bit more detail at a later date on certain subjects. But as I say, today is more of an overview and a chance to just bring our community together to discuss and look at the issues surrounding air pollution and how it affects ESG. I would ask you all just to keep yourselves on mute for the time being, please. And there'll be 4 sections today. And if you can just drop your questions into the chat as we go along, and we'll try our best to answer them at the end of the session. If specifically you want to direct your questions to one of the presenters in particular, if you could just let us know who that is, that'll just help a little bit as well. Thank you very much. So, first off, I'm going to hand over, I'm just going to show you the agenda first. So you'll see that we've got 4 sections we're going to talk about today. So Harry will start off talking about global air quality and mitigation. I myself will just take you through a brief overview of ESG and air pollution and how they correlate. We have a guest speaker who will introduce as we come, talking about making buildings healthier. And then Harry will come back on to just explaining briefly a bit of shameless plugging of how healthy air products help meet the challenges of air pollution in a modern world as well. So I shall pass over to Harry, who will introduce himself first and just take you through his section.
Okay, brilliant. I hope you can all hear me. I'm Harry Hollingworth, and I'm in charge of marketing for Healthy Air Technology. As Terry just went over in the agenda, I'm just going to take you through a bit about air quality worldwide, and then ways that air pollution are currently being addressed, and the kind of ways that we're going to have in the future to deal with this. So really, when talking about air quality, we're talking about 3 main things. It's often thought of as just air pollution. We talk about that a lot, but of course, there's more to it. You've got viruses, bacteria, and like various biological substances in the air. That's the first part of air quality. The second is, typical air pollution. So, chemical substances that stay in the air and that can damage our health by getting into our lungs and cause all sorts of problem in the body. And the third are, small particulate matter like PM2.5, so really small particles that we breathe in that can get into the bloodstream and damage us in a variety of other ways. So really, those, if everyone can just make sure they're on mute, by the way, I'd really appreciate that going forward. So really, these 3 components of air quality make up the air we breathe in any indoor or outdoor environment. Controlling the air outdoors is obviously significantly harder. But we do have ways to control it indoor, luckily, which we'll go over today. So why is air quality important, this topic? I mean, the first reason is quite obvious, which is that millions of people each year die prematurely, according to the WHO, the World Health Organization, because of low or poor air quality. So obviously there is a major need, in the same way that we talk about improving access to clean water or access to clean food, to also improve people's access to clean air worldwide. The second point is obviously the worldwide effects of air quality. 2.6 billion people are exposed to dangerous levels of household air pollution, again, coming from the World Health Organization. The number of PM2.5s, these small particulates in the air that can damage your health, the safe level of those, the WHO recommends, is around 5, and almost no urban center, I'd wager none, really is under 5. So almost everyone who's living in a city is being exposed to unhealthy levels. And around the world, this problem is even more significant. In kind of rural areas where we think of breathing like fresh air or clean air, that's often just not the case. COVID-19 has obviously brought a lot of attention to the air we breathe. Luckily, people are beginning to take more notice of it and deal with the air in an indoor space, doing things like ventilating. In schools, obviously, people were doing things like opening windows or doors. Unfortunately, that isn't often enough to completely reduce infection. But the pandemic has shown that this is a seriously pressing issue. You know, there's potential for other pandemics in the future. This one itself is still ongoing. As much as we might all want to hope it's over and get back to our lives, I don't think that's the case just yet. And there have been, you know, millions of deaths worldwide, and the economic impacts have been, you know, extremely significant for every country around the globe. So, you know, clearly we should begin, I think, to think of air pollution, air quality as connected to our worldwide environment and our economy and nations in the same way we would clean water. Lots of countries around the world are facing water crises. I think we're all equally facing an air crisis, which COVID-19 brought attention to. I think it's important that we keep that attention on the topic. So health impacts of low air quality, it's not just death. There's also a variety of other impacts it can have. Asthma, aggravating, you know, illnesses like asthma is one thing, or you're bringing them on in children. You've also got pneumonia in children under 5, which can be brought on through low air quality. Certain countries, particularly Nigeria off the top of my head, struggle with this in a very significant way. And around the world, there's a huge amount of pneumonia cases brought on by air pollution, but it really extends to all sorts of other illnesses. Just your general health can be aggravated by it. And especially in the young where it's worse, this can be a major problem. And then one of the major problems we have with air quality worldwide is just a lack of awareness about it. A lot of countries who do have the power to legally mandate, you know, outdoor air quality or are required to by the UN just don't do anything about it. And like I mentioned with the PM 2.5s earlier, 92% of the world population live in places where the air pollution levels are exceeding safe limits on this. This is what I tried to touch on a moment ago with water and food too. People are very conscious about these things with their health. And while COVID-19's brought attention to the topic of our air, not everyone is as equally kind of laser focused on the air we breathe. And we need to make sure that both people generally in society have an awareness of this, but also governments, businesses, institutions have an understanding of the way in which air impacts, you know, customers or staff or, you know, people in a hospital or a library or whoever else it might be, and then take measures, hopefully, to improve the air in society generally, but also more specifically in the buildings which they do have control over. So that was just a brief overview of air quality worldwide. Now I'll just talk a bit about air pollution more broadly and the ways that exist to tackle it. So the first one, as I think we're all relatively aware of, is lowering carbon emissions. CO2 emissions contribute to exacerbating climate change. It's been shown that climate change, you know, through rising temperatures, more extreme weathers, also aggravates the problems of air pollution and just generally makes our air more difficult to breathe. It exacerbates kind of allergies. You know, things like hay fever can be aggravated by this. We have smog in cities, which is obviously like visually not nice, but actively damages our health in other ways too. So CO2 emissions and reducing them is clearly something that lots of states and people are dedicated to doing. It's about taking the next step and making sure that we understand how that's linked to air pollution. So alternative modes of travel can also help reduce air pollution and improve air quality locally. It's not just about electrification, having electric cars, but also things like walking, cycling, trams, trains. Obviously, things like a coach, a train can have a lot of indoor or, you know, in-vehicle air quality, air pollution issues. You can be exposed to a lot of the car fumes, or you know, if trains, depending on the train it is, if trains make them, the fumes there's also the risk of infection. So it is important that we think about, when moving away from cars, how we can control air quality in these different indoor environments. But it's generally an improvement to, you know, diesel or petrol cars, which do affect our health, and they affect everyone else's health when you go outside and breathe the fumes that they release. So promoting human rights is also extremely important in actually improving air pollution worldwide. It doesn't actively reduce the amount of pollution in the air in the same way that some of these other things do, but I think it's equally as important. Right now, the right to clean air does not exist in people's minds the same way that other rights exist. If I spoke about, for example, water quality and loss of the world, especially developing areas, people would acknowledge that this is something that needs to be worked on. The same degree of emotionality that people have around this topic does not yet exist for air, or it is, starting for some people. We really need to build on that, pressure MPs, politicians, businesses, other organizations, make sure that it is understood that the right to clean air is a human right that we all deserve. The next step that people can do to reduce air pollution or to tackle it is air purification. So obviously, an individual air purifier unit is not going to, take pollution out of the air outdoors and, clean the entire world or something. We can't just all have these machines and global warming will be over. But in an indoor environment, we have to acknowledge that we are going to be exposed to air pollution or low air quality, depending on where we live, especially if we're living in cities. But like I mentioned earlier, a lot of rural areas have very low air quality. There is no way to just fix the entire world's air pollution issues or your city's air pollution issues. What you can do is control what you're breathing, your family's breathing, staff and customers, and so on. And air purifiers and proper ventilation systems offer the opportunity to do that by killing bacteria, viruses, getting rid of things like NOx and SOx. And the last thing, again, we all need to be promoting awareness of the topic and focusing on COVID-19, the fact that the pandemic is not over and the way in which this ties to other issues. COVID-19 has been shown to be more damaging to people in areas where air pollution is at its worst. And we need to use things like this to make sure that everyone understands how damaging this can be and talk about these steps to improve it. So thank you for that, Terry. I'll hand it back to you now. I'll talk to you all again in a bit to go over healthy air technology.
Thanks, Harry, and a great start to the presentation. So I'd like to just give you a brief introduction into ESG and clean air. So ESG comprises of 3 pillars, like most sustainable metrics around the built environment and business. Different definitions of what each of the 3 pillars exist depending on who you talk to. I've chosen the World Economic Forum one here just to go over, which looks at the 3 pillars as environmental, social and governance. As you can see, we believe that the impacts of air pollution and a good air pollution strategy can impact on all 3 sections, with no surprise that the largest section that gets impacted is the social side, around things like health and safety of individuals, of clients, customers, as well as staff. Human rights with the access to clean air as well is impacted there on a wider scale. Working conditions, obviously, and employee relations, if you're providing clean air, can certainly help in terms of contractual agreements and interactions with unions and mitigating any litigation that may happen in certain areas and countries, depending on employment rights. And inclusion and diversity, of course, people who suffer with COPD or who have breathing issues would find it much easier to work in an environment where clean air and a safer environment is provided through purification as well. From the environmental section, energy efficiency, we'll touch on that, and the reason why we think that is paramount to a good air purification strategy in a moment. I have a slide on that. And emergency preparedness, as Harry has already said, we're not over the current pandemic. We have other pandemics on the horizon, I'm pretty sure, aside from the things like influenza and colds and any airborne-based transmissionable disease. A good air purification strategy can certainly help to minimize cross-infection within the workplace, and obviously then allows business continuity for places where people being on site is paramount as well. So really impacts on that around the ESG. And then ethical standards and corporate behaviour, obviously the way in which investors look at how companies treat their staff and their customers and their neighbours. So being able to expel cleaner air out of your building than what you take in through your air conditioning units certainly helps to impact that as well, depending upon the structure of which the ESG takes that companies measure. So let's just have a look at what really underpins ESG, and I guess it underpins sustainability in general, probably within the built environment to a certain extent. So in 2015, the United Nations adopted the 17 sustainable principle goals of sustainability. Within those, I think there's 169 key points that need to be addressed or looked at. And it looks at the global challenges of poverty, environmental protection, and it says by 2030, but it's an ongoing project in any case. And that looks at actions and impacts on a local, national and global scale. It looks at setting metrics by which they're measured and mitigations in which they can be dealt with. And that's an ongoing process. So ESG uses that pretty much as its underpinning science. And ESG itself can be verified or certified depending on the organization that you deal with. And as I say, those metrics under different verification bodies can have slightly different names, but they're all underpinned by the science that's presented here. And we're just going to go over a couple of those to show you what they look like in terms of air purification, because we could have a whole day on this, I'm pretty sure. So Sustainability Goal 3, good health and well-being, requires that a good air purification strategy, we think, will reduce airborne infections and fight against long-term health issues. That helps to reduce sick days and improving quality of life and productivity. So in terms of businesses, actually, an air purification strategy will not only increase performance within their staff, but it will reduce the sick days, and increase the profitability and the efficiency of the organization that adopts it. Reduced inequalities, which is Sustainability Goal 10. It's developing countries and urban centres with high levels of air pollution significantly benefit from access to clean air. Even in developed countries like the UK, we see there are a number of organisations and groups that are highlighting the inequality of air quality for people on lower income strategies, and people in poorer areas generally are in inner cities where there is higher percentage of NOx and SOx, and of course they've not got access to, potentially if someone's living in a low income housing development, the chances are they're not going to be able to afford a personal air purifier to keep themselves healthy. So obviously the impacts on people of lower income is much higher than it is on those that can afford to provide for themselves. And a good air purifier system is able to enable global access to clean indoor air, regardless of the outside air pollution, which is what we aim to achieve within the Healthy Air Technology Strategy. And then finally, Sustainability Goal 13, climate action. So this is about energy efficiency here. So I think it's common knowledge for anybody in the built environment, or should be, that the reduction of energy demand, the amount of energy you need to run a building, is the first step in becoming more energy efficient in buildings. So normally when we're talking about refurbishing or new buildings, it's higher insulation to reduce the heating load, and LED lighting to reduce the lighting load, etc. But the way air purification can impact on this in a very big way on larger buildings actually, is the reduced requirement for air exchange rates within the building. So the amount of fresh air that needs to come in to flush pollutants out of the indoor environment. And a good filtration system can actually reduce the requirement of the air intake. So thus obviously then reduces the energy load of the heating and ventilation strategy within the building as well. And as I say, on a very large building, especially ones that require heavily, that rely heavily on full stair ventilation, it can be quite a significant improvement on the energy efficiency of that particular building. And as I say, there are plenty of other sections within that we could go through that would demonstrate the impact on the built environment by using a good air purification strategy. But I think the three key ones are the ones that you've just highlighted there. So now I would just like to hand over to our guest speaker, George Adams, who is the Engineering Director at SPIE UK and is also the SPIE ex-president.
Good morning, Terence. Hopefully you can see me and hear me. In relationship to everything that's just been said, I've put together my thoughts about where we are at the moment in general, in terms of the built environment and in terms of the societal need to improve health. I'm going to put forward some points that will be hopefully a bit mind-stretching. And I'm certainly not going to go into a lot of technical detail that's already been covered quite adequately. And I think what I'm trying to do here is to raise some important questions that we need to think about for the future. I'm a practicing engineer, and therefore I come from an engineer's point of view, not a political point of view. And so the way I see it, based upon the current level of industry information, societal information that's available, that I've studied, and the experiences I've been through over the past 2.5 years with the COVID pandemic, has increased awareness of buildings that we occupy, with the significant impact that they have on our health, our well-being, the efficiency that we operate in, particularly in the commercial world, and of course the impacts on economy and our healthcare structures. But my view is that we should carry on and ask important questions for the future. We should not stop. And questions such as, are we truly defining what is a health safe building for people to live in and to work in? Are we truly doing that? Do we really understand and accept the complete impacts of buildings on people's health and on their safety and on the effect of society, particularly as we now grow more and more into the world of climate change and the impact that that has on our built environment? And also, should we, in relationship to buildings in the future, and I conclude in that existing buildings, which is my biggest level of interest, is to apply people's concerns about their health, about their well-being, both in the workplace and in their living place. And are we really getting to grips with how we can positively improve their life in order to improve the whole well-being of society that they live in? A healthy built environment should, by natural extension, in my view, encompass the energy efficiency of buildings, as human well-being and performance must be the centre of concerns, inclusive of the impact of the climate emergency. We know there is a lot of emphasis about energy efficiency, reducing carbon emissions. However, the fact is that we are in a position where the data shows us that in a building that has improved its health, its health position for people in it, can, in some circumstances, improve cognitive behaviour by up to as much as 60%. There is data around that kind of indicates that. The World Health Organization advises that the Europeans spend about 90% of our time in buildings. So I propose we must make both all of our existing buildings and our new buildings a much healthier place for people to be in, to contribute on how we live in a society that is becoming more urban centred. Okay, on to my second slide. Most of us now live in an economic system around the globe, and there are absolute human needs that those economic systems need to address, such as food, such as water supplies, accommodation, and healthcare. It needs to start addressing the needs of air quality, both in our cities and in the buildings we live in and the buildings we work in. with a population of somewhere around 7.5 to 7.8 billion people around the world. I'm never quite sure which figure is correct, and heading towards around 9.5 billion. We know that there's going to be about 2.5 billion people moving more and more into cities over the next 30 years. So with around about 65% of humanity living in cities by 2040, the year 2040, we are likely to be even more at risk in terms of a society, in terms of pandemics and transferable illnesses within the built environment. And we need, therefore, greater controls within the buildings, both existing and new buildings. You'll get right now my slight frustration about the continual addressing of what should a new building look like, rather than really addressing the buildings we have with now, and particularly the cities and urban areas that we have now. The need for individuals is usually met by being a member of a group that has a shared need, such as a family, an organisation, or a religion, or a political society. What we must include in all of these considerations is the basic fundamental need of good air quality, a healthy environment in which to live, no matter how you achieve your personal objectives, no matter what group you belong to. That is a common foundation, is to have decent air to breathe and live in. From all of this, surely it's important that we ask ourselves some questions. And my two key questions are, what should the world objective be for health? How should we define it, and what should it be? And can we, and how will we, politically, morally, culturally, make the improvements needed for a healthier and safer world to live in the future? I'll go on to my next slide, if I may. Right, now, in the UK, as an example, buildings have contributed about 40% of our emissions. Over the last 2 decades, that has reduced, mostly over the last 10 years, and largely attributed to the improvements in the electrical structure, the electrical infrastructure that provides our power to all our buildings, rather than the improvement of the energy efficiency of our existing buildings. That is a big challenge that has yet to be addressed in terms of implementation of making existing buildings much more efficient. However, about 80% of our buildings that we have today, and this is not uncommon around the world, will still be with us in 2050. So to me, there is a major and important requirement that our existing buildings are not only more energy efficient, but it's crucial that we actually make them healthier to live in, particularly with the impact of the growing concerns on the climate emergency. With the threat of future pandemics and the increasing urban density, which we will see around the world, we cannot simply reduce energy and carbon emissions. This must also work hand in glove with creating a healthier and safer built environment for people to be in. Basically, what I'm saying is you can't do one thing without the other. We have to address carbon emissions, we have to address energy efficiency, and we also have to address the needs of the health of people. Our health systems are stretching and being overstretched at times. When the pandemic came along, we saw all over the world how the health systems were being seriously stretched. We need to reduce that impact, but equally the economic problems that the pandemic brought. So if I just move on to my next slide. And this is the absolute need for healthier buildings. The built environment affects our health, our employment, our social interactions, and generally the well-being of us in society. However, most people are also largely spend most of their time in the built environment around the world, and which most research informs us does impact in several ways on our health within the indoor environment, such as air quality, the chemical contaminants, and of course the circulation of bacteria and viruses, which can hang around in the air for a long time There was a lot of thought at the beginning of the pandemic that perhaps it wasn't airborne, and perhaps even if it was airborne, it centered around that magical 2 meter zone around people. As the pandemic grew and we learned more and there was more research done, we then began to realize that actually the virus hangs around in the air on smaller droplets that come from people that are infected and can hang around for many hours within the built environment. We need to do something about that. We need to clean that air up to make buildings safe for people. However, I'd like to just mention that in the domestic scene, that the information that I've managed to get hold of says that about 1 in 6 Europeans, as an example, live in homes that also make them feel sick. Unhealthy buildings are therefore, without doubt, a widespread problem that needs addressing. Another good example that I've come across in the past is that, again, concentrating on Europe, if I may, is that around about 60 million European students and over 4 million teachers are affected by the quality of the air they breathe within their particular built environment. And that's another good example of why we need to make buildings much healthier places for people to be. Just slip on to my last slide, which, just bear with me a minute, sorry, yeah, you just slip onto my last slide, which really is going to raise a fairly important point, I believe, that we're not addressing at the moment. Unhealthy buildings are indeed a liability, and I suggest most of us do actually live and work in buildings that are not as healthy as they should be. Additionally, because of the changing climate presents a variety of risks to human health, a healthier built environment is an important part of the overall solution we need to address for the future. The general public is now actually more aware of the impact of unhealthy buildings, and owners, property owners, managers, businesses, insurance companies, and indeed governments will need to respond to this challenge. With the climate emergency, reducing energy consumption in buildings, particularly existing buildings, of course, is absolutely critical. But energy savings should go hand in hand with the protection of people's health within the built environment. If I may, I would actually just like to also stretch another point that might set us thinking a bit deeper. Epidemics have in the past spurred societal changes, and plagues, for example, have indeed led to significant changes in society and even political situations that arise from that. I'm not sure yet that in relationship to this, that the COVID pandemic has actually finished its journey yet. I think there is a long way to go yet. And we're seeing COVID settle itself more in the community and people becoming more acclimatized for it, but we don't know what the future holds. And my point is that we need to plan for future pandemics that may occur more frequently than perhaps we might like to think. So basically, my point is that COVID-19, we should learn from the past. We should learn more from the past about how pandemics have impacted on society in the past. What has it meant? What has it led to? We need to learn more so that we can try to understand what the future might bring. And why? Because we have much more medical and engineering technology now to assist us in reducing the risks in the future. What we need is to recognize that the investment in creating healthier built environment for people to live and work in is not just a cost, it's actually an investment in our future and the efficiency and the healthiness of our societies that we live in within a growing urban community. So my point is, we really need to spend much more time and effort in understanding what the future might look like. So hopefully that's been of some use, and more importantly, hopefully it's raised some questions that we all need to think about going forward. So thanks very much.
Thanks very much, George. What a great thought-provoking presentation, and I'm sure there'll be a few questions that'll come up from the audience on the back of that. And really put some meat on the bones and real life situation and scenarios around the development goals of the United Nations and ESG as well. So it brings it really into life. Next, Harry's going to come back and join us and just take you briefly through the healthy air technology range and how our purifiers actually address the impacts and the problems of air purification in a different way. Harry.
Okay, brilliant. So thanks, George, for going over that. I felt that was really just a comprehensive talk about the topic and about the need to make buildings healthier. So I'm going to tell you a bit about healthy air technology before we move on to questions, and what we do, what we believe that we do the best, or one of the best, to make buildings healthier. So we're healthy air technology, and we develop and manufacture a range of purifiers that use a unique technology to be able to destroy bacteria, viruses, and chemical pollutants and PM 2.5s from the air, essentially making all of the air sucked into the machine released completely purified and clean and healthy. We use an innovative piece of technology that we call our DNO technology, or the DNO catalyst, which was developed by an Oxford University scientist, our lead researcher. And this is really the heart of our machines. It's what sets us apart from other purification systems on the market, which traditionally use HEPA filters. HEPA filters on their own, we believe, and I think there's a growing body of research to show, are not sufficient for an indoor air purification system. So we have developed this unique catalyst that works alongside the filters, which is able to take them the next step. And it's able to completely kill bacteria and viruses, which HEPA filters on their own are not really able to do. And it's also able to completely break down chemicals like NOx, SOx, formaldehyde, instead of just trapping it in the machine. So on our technology, we're currently developing smart integration systems to allow our machines to better interface with building systems, to kind of move forward with this plan of making buildings healthier and letting you control what you can do. And we also employ what is called computational fluid dynamics, or CFD, to keep it nice and short, which is a fancy way of saying that our machines are equipped with an air purification or an air distribution system, which moves the air around the room completely. It blows it up to the top of the room in like a mushroom cloud shape, and then around the walls, across the floor, and back into the machine. And it moves the air around the room in such a way that it helps dissipate bacteria and viruses. Or more simply put, normal air purifiers kind of suck air in, blow it out, and then suck the air back in they've just released. Well, we've developed a system that is able to prevent this and get air everywhere around the room that's nice and clean. So, like I was just talking about, we believe that we've really perfected air purification with our unique solution. We're using the best filtration that's available on the industry. The design of our machines have won a Red Dot Award, and they have been for the design, and they have been designed to kind of optimally distribute air everywhere as clean as possible. So like I was talking about a moment ago, thanks for Terry, we've got what is called the DNO technology, which is at the heart of our machines. And what this does is it works in conjunction, as you can see here, with the other filters, the primary filter, the HEPA filters, to completely break down anything that is sucked into the machine. Other air purification systems that currently exist are like UV. There's like a UV light system, which attempts to completely kill bacteria, viruses, things like that. It's quite effective in removing harmful substances from the air, but it has a lot of health problems that it can bring. It's not entirely safe. Like I mentioned, just a HEPA filter alone is not enough. There's other purification systems, and we feel that what our solution does it better than all of them, and importantly, cheaper and more efficiently as well. Terry, during the ESG segment, talked about how a proper air purification system can reduce the energy bill. And George just brilliantly went over how we need to make buildings more energy efficient. And that is what our products are able to do. They are so efficient at cleaning the air and releasing fresh air back in that they reduce the amount that is required to be pumped into a building by a ventilation system or a heating or cooling system, which in turn significantly reduces the energy bill and actually lowers the carbon footprint of a given building, because the heavy lifting systems are doing significantly less as they require less air. So we have 4 different machines, our different solutions. The HA500, which is a tower unit that's designed for the home, but really can fit in any indoor environment as well, like a smaller office, even certain rooms in like a library or so on. The HA800 is an upscaled version of the HA500. It's more powerful. I think it's just as energy efficient, really for large offices, large buildings, schools as well. And they all 4 of the units use our DNO technology. Those 2, the HA500 and 800, are for larger spaces. We've then got the HA55, which is a desktop air purifier. There's a wall-mounted version as well, which is for a smaller area like an elevator, a small room, a bathroom, and kind of local zones. And finally, we have the HA30, which is for transport. It's a car air purifier. And you put this in your car, it will tell you the level of pollution, and you can see it kind of change by the colors on the machine. I believe blue is the lowest, red is the highest. It's quite intuitive to tell what's happening. And you can see, depending on the area you're driving through, what the air quality is like outdoors. And the machine, importantly, sucks in all of the harmful bits, purifies it, and then releases clean air to you. It's important to note that all of our machines work alongside existing ventilation systems. So, if you've already got something in the building, these are just plugged in and they work alongside them. There's no kind of additional installation or problems that they can cause. Yeah, so if you can just go back 2 slides really quickly, Terry. Thank you. Yeah, so just the last thing to mention, now that we've had a look at the different products, that the HA500 and 800, the larger units, they are currently being used in hospitals and dentists. These are medical grade, all 4 of them are medical grade air purifiers at about 1/4 or 1/5 of the cost of similar units used in hospitals currently. So, our goal in developing this technology is really to bring the highest grade of air purification using this new technology to everyone at a much cheaper cost. So with that, I think we can move on to the Q&A. I wanted to leave enough time for us to do so. So I'll hand it back to you, Terry, and we can start going over some questions.
Thanks, Harry. Thank you very much. Just stop my video again. So has anybody got any questions? If you don't want to type them in the chat box, if you just want to just say yes or whatever, and I'll bring you in if you have any questions for anybody. Any points anybody wants to make? Whilst we're waiting for you to do that, just one of the things just to add to Harry's last section, some of the issues with using UV to kill viruses and bacteria is that the byproduct of that purification is the release of ozone. And whilst it is in small amounts, it is still releasing ozone. The DNO technology, because it kills the bacteria on the filter itself, has no secondary release other than small amounts of CO2 and H2O. So it's completely inert, anything that comes out of the machines. Yeah, the recording, we will send that out to all of the participants. Harry will send that post presentation. Has anybody got anything they want to add? Last call before we wrap up.
George has his hand up.
Yeah,
Yes,
just put my hand up.
sorry, I didn't see that. I saw you appear. I didn't see the hand, George. Sorry.
Okay. My question is a little bit more granular than what I presented, but one thing that I do think we need to take on board is the effect of humidity control in buildings and in relationship to the ability of a virus to transmit from person to person. So when we're considering the way in which technology works to help us make buildings safer, we should also take the benefit of improved humidity control as well of what has been discussed today. many buildings don't have any humidity control. Most buildings, in fact, don't. And those buildings that do often switch it off for an energy point of view. But controlling humidity within the band of about 40 to 60% within normal temperature ranges can assist us in making technology such as what you're putting forward today work even better to control the environment to control the virus within a space, to actually make people healthier, because humidity control has other benefits as well. So we should never ignore the fact that all the things need to be considered: the temperatures, the humidities, and the bacteria and the viruses that can circulate within buildings, and the technology that can help to remove those viruses and bacteria, but working with the basics as well. It all needs to work together, is my point.
Thanks, George. And whilst you've been talking, it's great to give people a chance to put a few questions in. So we've had 3 questions. First one from Glyn. And I'm going to put, Glyn was, have you conducted any monitoring in your treated areas to assess effectiveness of filtration units? I'll preempt that answer with all of the units have been tested in laboratory conditions, certainly for viruses and their effectiveness, and they all achieve more than 99% effectiveness. It's like 99.5, 99.7, and that includes H1N1 bird flu, which is the same virus as coronavirus. It's currently illegal to test against H19 bird coronavirus. We just can't get hold of it, and then no test house will do it. But the factor for us in killing viruses isn't the virus, it's the size of the particles. And we can go down to 0.013 particle size, which is well below the size of current viruses that are airborne, that are causing problems around the world at the moment. And then in connection with that question, bear with me. Julian asked, how well does the system work for really bad pollution in cities or along busy congested roads? So real world monitoring, we haven't got any complete studies at the moment, but we have one ongoing at the moment, and I hope I could mention the company name, Chun-Li, but I'm going to mention it anyway. Cornwall Council have bought 13 units for a congested village, and they did extensive market research on units that they would use, and currently in the marketplace, I believe we're the only unit that can effectively neutralise NOx and SOx. So they've put, actually it was 16 units in houses alongside a busy road that suffers from massive pollution, especially in the summertime, because it's the main route down into South Cornwall. And they've done some monitoring before our units went in and after the units went in, and they're working in conjunction with the university to evaluate that data. We haven't got access to that data just now, but we will have once it's completed. But the feedback from the residents is that they've noticed a vast difference already based on our contact and the feedback our contact at the council's had who's running that project. So it's quite positive in that respect. Merengue, yes, the presentation slides will be sent after the presentation is finished.
Just to clarify as well, I'll put a link to them on LinkedIn, and I'll also just send an email out including them. Great,
thanks, Harry. Asuquo has asked, is there a way to test for viruses and bacteria in a room? Just because most air quality monomer tests particulate matter. Well, if you consider that, if we talk about COVID-19, for instance, the way we know if people have got it, there's a 15-minute wait. So there'll always be a lag anyway. And currently, I don't believe there's a system effectively for a machine to actively, instantaneously measure the level of bacteria in a room, which is why we go for PM 2.5 meters, because obviously we're measuring the size of the particles. If we're dealing with the particles anyway, we're dealing with the viruses, because the viruses are sucked up in exactly the same way. So there is a correlation between the two of them. Of course, we can't mitigate that if somebody walks in the room and coughs over everybody before the machine can get hold of that. But certainly the background and the ambient air purification is indicated by the PM 2.5 monitors that display on our machines. Was there anything else that I've missed?
Yeah,
done the congested road. Yes, Chun-Li.
There's a question about efficiency as well.
Oh yes, sorry, I did see that and then forgot about it. Yeah, so that come from Marenga. What's the efficiency of the units? So the HA 500 cleans 500 cubic meters of air an hour, and the 800 is 800. Hence why the numbers. In terms of efficiency, the 500 unit consumes 45 watts of power, and the larger unit is 80 watts of power. So pretty much like for like is the equivalent of an old tungsten light bulb, filament light bulb. It's so low efficiency, and that's the efficiency is improved by the way we have the two fans sucking in and using that mushroom effect that Harry talked about, so that we're able to get a greater coverage without high energy loads going through the fans. They're super efficient. Any other questions at all? One new message at the bottom. What have we got? Maybe one for you, Chun-Li. Can the filters be regarded as bio-waste, and what's the best way to dispose of them?
No, it isn't, because for our system, the HEPA will catch some of the bacteria and the viruses and particles, and but all these bacteria and the viruses will be dead, and in about 2 hours. So generally speaking, you will that will be dead when you dispose it. But if there's some viruses or bacteria escaped HEPA, and the DNO material will catch it, and that will be killed very quickly, almost instantly on the material. So that's one of the advantages of the our core technology, DNO.
Brilliant, thank you. And just for clarification, Chun-Li is the MD of Healthy Air Technology and also the engineer that designed the CFD pattern to be able to distribute the air successfully. So she's key to the success of the product in more ways than one.
Thank you.
Okay, if we haven't got any more questions, because we are 2 minutes early, I'd like to say thank you to everybody for coming. As we've already covered, the presentations will be available to you. If you have any further questions post this, please do email them to us. You'll see, if I come off there, our details there. And you can address that to Harry, Chun-Li or myself, and we'll happily answer those for you at a future date. And of course, if you have any more questions about healthy air and how it can help your clients, then we're more than happy to help those. And finally, I would just like to thank once again George for coming along and being very generous with his time and thoughts and giving us an insight into his perspectives on air quality within the built environment.
Pleasure.
Thank you, everybody. Thanks very much.
Brilliant. Thank you all so much.
Chun-Li,
Yeah.
can you hang on for a moment?
Okay. Yeah. No problem.
Do you want to stop the recording then, Chun-Li?
Yeah.